This is part one of a two-part series on understanding congruence through transformations. Now, how can transformations be used to determine congruence? First of all, we have to understand that congruence means that figures have the same size and the same shape. We use this symbol with an equal sign with a curvy line above it, and that means is congruent to. So when we see this symbol, we know we're talking about two figures that are basically exactly the same. They're pretty much equal. But the reason they're not exactly equal is because they've been transformed, they've been moved. So what we want to do is use transformations to help us prove congruence. Now there are three types of transformations that we look at. We look at translations, which is a slide of a figure. We look at reflections, which is a flip of a figure. And we look at rotations, which is a spin of a figure. We use these to help us to prove that one shape goes on top of another shape and to prove that they are congruent or that they are equal. So let's take a look here at a trapezoid ABCD, and let's prove that it's congruent to WXYZ. Now the way we're going to do this is by recording a sequence. Well, let's take this trapezoid and let's slide it over. 1, 2, 3, 4, 5, 6, 7. So we see that it slides over 7. So let's record that. If we're going to slide 7 to the right, we're basically translate 7 to the right. Now we're going to write a rule for this. Okay, so that means we're going to take the original trapezoid, which is XY, and we're going to change the X by 7, which means we're going to slide to the right, and we're going to leave the Y alone, which means we're not going to move up and down. Now our next step is that we need to flip this trapezoid over. And when we flip it over, it's going to flip over the x-axis and land right on top of it there. So that's going to be our second step. We're going to reflect, because that's what flipping is, reflect over the x-axis. And then we land right on top of the other trapezoid, and we can show they're congruent. Now, are there other ways to do this? Sure there is. We could have, from the beginning, flipped that over first, which would be our reflection. And again, since it's 2 away from the x-axis, we're going to move 2 away from the x-axis again. We will be there. So we could have done this first, reflect over the x-axis, and then we could have translated 7 to the right. And again, and it right on top of that. So we could have done it the other way as well. So we can see through translations and reflections and rotations, we can prove congruence by coming in different directions, just by transforming the original pre-image to the new image. Now, one of the things we have to be able to do is to talk about congruent parts. So let's take a look and see what parts are the same. So if we're talking angle A on the original pre-image, we know that angle A is congruent to angle W. So let's record that. We know that angle B is congruent to angle X, because we just showed that it flipped over, didn't we? We know that angle C is the same as angle Y, and we know that angle D is the same as angle Z. So now that would give us our congruent parts on angles. Let's talk about sides. So side AB would be congruent to WX. And again, we want to go in the same direction. Since we start from AB, when we flip over, it would be WX. BC, which is the long side here, would be congruent to XY. Side CD would be congruent to YZ. And side DA would be congruent to ZW. And we could have used our angles as a helper too here. AB, AB, BC, BC, XY, CD, YZ, DA, ZW. So we can see that that connects as well. That's the end of this lesson.